Hello guys, nice to see you again. Today we will work with the applied integration problems involving displacement, velocity and acceleration. Before that, we will recall some of the previous studies that we have with these three quantities, displacement, velocity and acceleration. We know from our previous studies that acceleration is derivative of velocity in terms of the time. From this equation, we can say dv is equal a dt. We integral both sides. Integral dv is equal to integral a dt. And finally, v is equal integral a dt. So we have the first equation. Okay, we will place it here. V is equal integral a dt. We also know that velocity is derivative of displacement. V is equal ds over dt, or ds is equal v times dt. We integral both sides. Integral ds is equal integral v dt, and finally s is equal integral v dt. Okay, we have the second equation. We place it here. S is equal integral v dt. Okay, we have these two equations. We will work with few examples to understand better this concept. Example 1. A truck traveling along a highway at a velocity of 30 meters per second. In an emergency, the driver can apply the brakes such that the acceleration will be a is equal minus 17 meters per second square. Determine the distance in meters per second that the truck will need to stop. A very interesting problem. We will try to create this scenario. I have my favorite toys. Since my 5 years old, I am playing with them. Yes, we have the truck at this point. We have a multi-vehicle collision happening at this point here. Approximately, I would say, maybe 60 meters, around 60 meters from the truck when it applies the brake, approximately 60 meters. Okay, here we have my favorite car, my Beetle, traveling behind the truck. So the driver applies the brake at this point here. We have the initial displacement. Initial time is 0. Initial velocity is 30 meters per second. We also have the acceleration is minus 7t. The driver applies the brake and the truck just slows down, and the plan is to stop before the collision at this point here. At this point, the velocity, the final velocity will be 0. We are looking for the final distance. We also have the time here, but we don't know it. And probably we will need to find it during the solution of the problem. We will use the first equation. Velocity is equal integral of acceleration. We have the acceleration, right? We can write minus 7t dt, or velocity will be minus 7 over 2 t squared plus c, constant of integration. We can call c1, as we will need to integrate one more time. And to avoid confusion, the second one we will call it C2. we need to find C1. We look at the given information we have at this point here. We have here velocity, we have time. So we will get velocity and time. T0, V30, then 30 is equal to minus 7 over 2 is minus 3.5. T is 0 square plus C1. Now we can see easily this term will be 0, then C1 will be 30. As C1 is 30, we can write the complete equation of the velocity. Velocity is minus 3.5 t squared plus 30. So we have this information right now. On another hand, we know displacement is integral of velocity. Displacement is integral of velocity dt. We have the velocity. So that's, I just draw a line here, okay, to avoid mistakes. We will have integral minus 3.5 t squared plus 30 dt, or S is equal minus 3.5 over 3 t cubed plus 30t plus constant of integration. This time we can call it C2. This is the equation of displacement, but we need to find the constant of integration. We will back to the initial information that we have here. Displacement 0 times 0. We apply these two values in equation. Displacement is 0 is equal minus 3.5 over 3 0 cube plus 30 0 plus C2. Here is 0, here is 0, then C2 is equal to 0. And the equation of the displacement S will be minus 3.5 3 t cube plus 30t. As C2 is 0, we just stop here. We have the equation of displacement. With this equation, we can find the distance at any time, but we are interested to find this distance at the final time, when the truck stops completely. We have the equation of velocity here. The velocity is 0 at the final point, so we can use this equation. Velocity is equal minus 3.5 t squared plus 30. And we have here this information. V is 0, so 0 is equal minus 3.5 t squared plus 30. We solve this equation to find the final time. From this equation, we have t squared is equal 30 over 3.5. As time is a scalar quantity, we can accept only the positive answer of this equation. So please, John, could you use your calculator to perform this calculation and give me the result for the time? Fantastic. Time is equal to 2.9277 seconds. Do you guys agree with John's result? Perfect. So we have the time, the final time. We have the equation of displacement. We will apply the final time in this equation to find the final distance. S will be minus 3.5 over 3. The time is 2.9277 to the power of 3 plus 30 times 2.9277. Okay, Sarah, would you please use your calculator to find the final distance? Yes, fantastic. The final distance is 58.55479 meter. Fantastic. So we have this answer here. We will compare with the distance, initial distance until the point of collision is 60 meters, and wonderful. The truck driver, he could avoid the accident and to make it worse. Okay guys, thank you to watch this example. We will work with other examples. I will display the example 2 on the board using projector. Give you guys few minutes. You guys can call me if you need any help, and I am sure you will be able to solve it. Thank you very much.